For decades, we believed a series of 540 million-year-old markings in South American rock were the first tracks of crawling animals. These tiny trails stood as the evidence for animal movement right at the dawn of the Cambrian explosion. Scientists pointed to these fossils as proof that complex behavior existed before the great diversification of life began. A stunning 2026 study has just revealed that these supposed worm tracks were never made by animals at all. Advanced analysis of the Brazilian and Uruguayan fossils found preserved organic matter that tells a completely different story. The signatures inside these rocks belong to microbial mats, which are layered communities of algae and bacteria. These ancient colonies grew on the seafloor and form patterns that perfectly mimic the appearance of animal burrows. This discovery means one of our oldest pieces of evidence for animal locomotion has vanished from the record. During the Cambrian explosion, Earth saw a sudden burst of new body plans and complex biological activities. We rely on trace fossils like tracks and burrows to understand how early organisms interacted with their environment. Unlike body fossils, these markings reveal what an animal was actually doing, like hunting or digging. If microbial mats can create deceptive fakes, then much of our early history of movement might be misidentified. These mats were dynamic systems that stretched and folded like elastic membranes under the pressure of ocean currents. When a mat tears or wrinkles, it leaves behind grooves that look exactly like the trails of a small worm. Certain types of bacteria even move in coordinated lines, creating net-like patterns that fool the naked eye. Distinguishing between a living creature and a physical ripple in a bacterial colony is a massive challenge for researchers. This correction pushes the confirmed date for animal movement further forward in the timeline of life. It suggests the transition from a world dominated by microbes to one filled with animals was a slower process. This shift highlights the importance of using chemical analysis rather than just looking at the shape of a fossil. Modern paleontology now uses Raman spectroscopy to find the true biological code hidden within ancient stone. Science constantly revises itself as new tools allow us to look closer at the mysteries of our past. Even without these specific tracks, the Cambrian period remains the most significant era of biological change in history. Understanding our origins requires us to be willing to admit when a long-held theory needs to change. Follow our channel for more investigations into the science of our planet. Visit our website to test your knowledge with our latest interactive quizzes. Every discovery brings us one step closer to understanding the complex history of life on Earth.